All right, so now we're done of 3 sections in the textbook. We have 8.1, which are one-step algebraic equations. You have 8.2, which are two-step algebraic equations that utilize either fractions or decimals. And then finally 8.3, which utilizes distributive property or fractions with numerators that are more than a monomial. In this case here, a binomial numerator. So for all 3 sections, we have different ways to solve them. And I'm going to go through the processes for all of them again as practice. So again, if you're using this as a practice test review, press pause now, try them again, or try one question at a time. Press pause and see if your solution was correct. Now for the first one, a grade 9 question is a grade 8 question would be something like this, and a grade 7 question would be something like this, where all we have is a numerical coefficient and an equivalent value. In grade 9, what they've done is they've made that 2 coefficient into something slightly more complex, or that -2 coefficient. They made it into a fraction, in this case, -1.5. But if we think about how would I solve this question, in most cases, if you rewrite the question to make something more familiar, like a grade 7 or 8 question, you would know that you would divide both sides by 2 to get the answer. So because the process for getting rid of a coefficient is that, I'm going to divide both sides by -1.5. And I know that dividing both sides by -1.5 will get me x. Okay? But over here, dividing by -1.5 is the same thing as dividing by -3/2. And we know that when we divide fractions, we really want to multiply by the reciprocal. So the same process of dividing both sides by -1.5 is to multiply by the reciprocal, which is -2/3. Now, if you're not crazy about cross reduction, now would be a good time to learn it because it really, really makes things simpler. Think about the fraction being over the other direction. So 3/3 would reduce down to 1/1. -2/8 would be -1/4. And when I'm done, x would equal -1/4. Now, if you're not crazy about it and you don't want to do it ever, you don't ever have to do it because you will end up with x equals -6/24. And you can reduce that down to -1/4 because both 6 and 24 have 6 as a common factor. In the second question, x over 4.3, a grade 7 version would be this, right? X over 2 equals 4, and in that case, you would multiply both sides by 2. So in our second example, we're simply going to multiply both sides by 4.3, multiply by 4.3, and x will equal the product of 1.7 and 4.3, so 1.7 multiplied by 4.3, 7.31, and that's the value of x. That's a pretty easy one. And the third one in section 8.1 is kind of a trick question because it's not really a one-step equation. It's a two-step equation. I'll show you why. In grade 8, you briefly learned something like this. 2 over x equals 4. Or we'll go 12 over x equals 4. That's a better one. And in grade 8, you might have learned you multiply both sides by x to start. And you get 12 equals 4x. And then you divided both sides by 4 in your second step and got x equals 3. Okay? That was one of those trick questions where your variable was in your denominator and it just made it into one further step. The same process is still true here. I'm going to still multiply both sides by x to start. I'm going to get -2.4 equals 1.3x. Once you have that, divide both sides by the coefficient of 1.3, and x will equal, well, I know it's going to be negative. I don't have to worry about putting that into the calculator because a negative divided by a positive is a negative. So 2.4, that's not 2.4. 2.4, that's not 2.4. Come on now, 2.4. Divided by 1.3 equals. So now we have a repeating decimal, and if we really look at it, we can see that it's 846,153, 846,153, 846,153, 846,153, 846,153 with a line above it, or approximately equal to -0.8-ish. Oh, 1/8, is it? My apologies. Oh, 1 point, sorry, 1.8. There we go, ish. 1.8-ish. Okay, in your second questions here, we have 8.2. A grade 8 version would have been, or grade 7 version would have been something like this. Okay, and in the grade 7 or 8 version, you would add 1 to both sides to get rid of your constant, then you would multiply both sides by 2. So as long as you can see that these two questions are similar, you're going to get rid of your constant by adding it to both sides. You're going to get x divided by 1.5 equals for 5.25. 5.25. Then you're going to multiply both sides by 1.5. Multiply by 1.5. And x will equal the product of 5.25. 5.25, good God. Multiplied by 1.5 equals 7. Because it's terminating, I'm going to use all the decimals. 7.875 exactly. Now, the next two questions have a lot of fractions. And what you learned in 8.2 is that when you have equations that contain fractions, one of the easiest things to do to avoid working with fractions is to multiply both sides by a common multiple that all of the denominators in the equation share. So if we look at this first one, denominator of 3, denominator of 2, denominator of 6, if I was to examine all of the multiples of each, that's a 6, the first one they would share is 6, okay? So because they share 6 as a denominator, I better rise this up a little bit here. Because they share 6 as a denominator, I'll delete those. What we can do is we can multiply both sides by 6. So I'm going to multiply this side by 6, and I'm going to multiply this side by 6, and we're going to see what happens here. So before I go any further, 2/3 x, if you have a coefficient of a fraction in front of a variable, remember this could be written this way, it could be written this way, or more importantly, you could write it, since 2/3 times x is really this, because that's what coefficients do, the most important way to see it is you can also write it that way. So these three things are the exact same thing. So 2/3 x, or 0.6 repeating x, or 2x over 3, they all are the same thing. And in this case, because I'm multiplying both sides by 6, it's probably best that I take that x and I put it in the numerator here, okay? So I'm going to think of 2/3 x as being 2x over 3, because 2/3 x is the same thing, again, just one last time, as multiplying it by x, which means 2 times x is 2x, 3 times 1 is 3. So they are the same thing, they just look completely different. So when I multiply this by 6, and I multiply this by 6, oh, not negative 6, 6. Yeah, that'll be darn. Multiply it by 6, and I multiply this by 6, I'm going to create no more fractions. So cross-reduce, for those of you who don't do it, you should. 2x times 2 is going to be 4x. Cross-reduce, this becomes a 3. Negative 3 times, or negative 1 times 3 is negative 3. And cross-reduce is gone. I'm left with just negative 5. Once I get it down to this, which there's a lot of ink on this page, now all I have to do is use my grade 7 cents or grade 8 cents to isolate the variable. Add 3 to both sides. 4x equals negative 2. Divide both sides by 4. And x will equal negative 2 over 4, or negative 1 over 2. Or if you want to do it as a decimal, negative 0.5. Okay? And I'll move that over. How much time do we got left? Okay, good. Yes, I guess we do. In the third question, this is a much easier version of it. If I just put bracket and multiply by 10, or sorry, about 30, and multiply by 30, I can see that the 2, the 5, and the 30, the first multiple all of those denominators in the equation share is 30. So I'm going to multiply by 30, and I'm going to utilize distributive property. X over 2 times 30 will be 30x over 2, or simply 15x. 30 multiplied by 3/5. Cross reduce, I get 6. I'm going to get 18, or a positive 18. And over here, cross reduce, it's gone, equals negative 8. All right, subtract 18 from both sides. 15x is going to equal negative 36. I'm running out of room here. Divide both sides by 15. I have no idea what negative 36 divided by 15. Oh, yes, I do. Do I? Well, who cares? 36 divided by 15 is 2.4. So x will equal negative 2.4. Now, let's go back in time and not do it by multiplying both sides by the same number. Come on now, you can do this. Perfect. So let's pretend I didn't multiply both sides by that common number. I could have subtracted 3/5 from both sides. Okay? X over 2 equals, find your common denominator, make your equivalent fractions, right? I think that's, yeah. It's going to be negative 26 over 30, I think. Negative 26 over 30. Multiply both sides by 2. And you're going to get x equals negative 52 over 30, which is x equals negative 1 and 22/30, which is negative 1 and 11/15. Is that what I had before? Did I make a mistake there? Is that what I had last time? Kenzie, is that what I had? Is that the same answer as I had before? Where did I make my mistake? All right, well, I made a mistake here somewhere, but it's too late to go back because I've already recorded it. So ignore everything I've said and just pretend you multiply. Let's do it again. All right, let's do it one more time. Hang on. Okay, apparently I made a mistake in the first one, not the second one. So we're going to do the first one more time and see where I made my mistake. So I'm going to multiply both sides by 30. And that should take equivalency. This is going to be 15x plus 18 equals negative 8. Oh, I know where I made my mistake, right here. I subtracted 18 from both sides. I know what I got wrong. It's 15x equals negative 26. And I think I put 36 last time, didn't I? Right? So then divide both sides by 15, and x will equal negative 26 over 15, which is negative 1 and 11/15. There's your answer. Yeah. I added, my mistake was right here. I think if you watch the video again, I think I got negative 36 there. Oops. Okay, in question 8.3, the ones we were working on today, that's the last one I want you to really focus in on. There are two options for this one. You can expand using distributive property, or more importantly, you can divide both sides by 4. Just to show of hands, when you did 8.3, how many divided both sides by 4? How many expanded using distributive property? Okay, we have both. So I'm very quickly going to do both. I'm going to expand first. If you expanded, you got this. And I'm not going to show you how to isolate from there because you should be able to do that. It's pretty easy. Add 12 to both sides and then divide both sides by 8.4. If you divided first rather than expansion, instead of having 4 groups of this, by dividing by 4, you're going to have 1 group of this. And if you divided that side by 4, you divide this side by 4, you get negative 3.2. Then you would add 3 to both sides and divide both sides by 2.1. So if I added 3 to both sides, I get 2.1x equals 0.2 negatives. Divide by 2.1, that's the world's worst 2. X will equal 0.2 divided by 2.1 equals, is that what you got? Okay, 0.095-ish, roughly x. Is that what you got? Was that? Yeah, we're good. And your final one, final two, excuse me. I'm going to expand this, see what happens. So I get half of x, or better yet, instead of writing half of x plus the product of a half and 4/5, which would be 4/10. and 4/10 in lowest terms is 2/5 equals negative 3/8. I'm going to subtract 2/5 from both sides. Half of x is equal to, common denominator of 40, negative 15/40 minus 16/40, keep flip change, negative 31/40 when I subtract those two, because you got to keep flip change. Multiply both sides by 2. X will equal negative 62/40, or 40th, that's 4, or negative 1 and 22/40, or negative 1 and 11/20. Didn't I? Oh, okay. Yeah. Negative 1 and 11/20 is your answer for that. Holy moly, we're running out of space and time. Let's see if we can get one more. The last question, we have 4.1 as my denominator. I'm going to multiply both sides by 4.1. That's going to give me x plus 3.2 equals the product of negative 1.73. 1.73 multiplied by 4.1. That's 7.093. Last step is simply to subtract 3.2 from both sides. And Bob's your stinking uncle. Subtract 3.2 from here. Subtract 3.2. X equals 3.893. How many had that last one right? Not many. How many screwed it up somewhere along the line? Oh, that's a negative one. Oh, I got to change my vote then. Negative 10.293. Is that better? All right. Ladies and gentlemen, that concludes it.